I'm Nicole Toomey Davis. I'm the president and CEO of Enclavix LLC, and I welcome you to this session on the risks and rewards of artificial intelligence. I want to share with you that when I saw the conference topic for this year's conference, I really wanted to propose this topic. And your conference committee selected it because they said AI is here to stay. And I wholeheartedly agree with that. I hope that at the end of today's session, you'll have a much better appreciation of some of the rewards of AI and also some of the risks, so that as you counsel your entrepreneurs, you can help them assess both of those things as they contemplate AI in their business. As I said, I'm Nicole Toomey Davis, and I'm the president and CEO of Enclavix, which is an artificial intelligence company. So let me just start by saying I'm a fan. I believe in AI and the power that it can deliver to businesses. There's a lot of great opportunities. I'm also a serial entrepreneur. I've raised millions in angel and venture capital. I've raised money from the SBIR program. I've sold a business to a public company. I'm an experienced corporate director, and I'm a CEO coach. I love entrepreneurship, and I love the work that you do in this SBDC community. The NSF funded our AI-powered Venturewrench library. And it's free, by the way, for entrepreneurs to use, for you to use at library.venturewrench.com. We're going to use the Venturewrench library as one of our examples today because I know it from the inside. So we'll talk a little bit more about it and how we use AI to pick those best resources to help entrepreneurs. So AI is being used and talked about everywhere, right? You hear about it all the time. You may also hear some other names or concepts that are also part of this AI universe. You may hear the phrase machine learning or deep learning, right, which is really the hot area right now. Deep learning is actually a subset of neural networking, and neural networking is part of the machine learning world. You may hear natural language processing, which is a companion to AI and to machine learning. You may hear phrases like image recognition or image processing, facial recognition, computer vision. When we talk about self-driving cars, we are talking about a multiple AI systems performing all kinds of activities. The most common type of artificial intelligence is what we call supervised. And that's what we're going to talk about today. That's basically we have an understanding of the pattern we're looking for. There's also unsupervised, but it's used less often. So I got to dispense with the Terminator, okay? Hollywood loves to depict the smart robot, the sentient AI system that's taking over the world. It's a great plot point, I guess. That is really what we think of as general AI or artificial general intelligence. We do not have that, okay? It's all faked in Hollywood. We don't have it. There are many people who believe we will never have it, some who believe we will. But we don't have anything like that right now where we really mimic in a computer the human brain or human intelligence. What we do have, which is still very powerful, is we have narrow AI or specialized AI. And this is artificial intelligence systems that do a very specific function. And we're going to drill into what that really means and how it helps us understand how AI works. So what does it mean? Okay, we are not going to read all these definitions, although they're here for you. And you can also look up in Wikipedia and online definitions of AI and some of these terms. But this is a working definition that I like, that I think is helpful. AI can identify patterns in large quantities of data much more accurately and quickly than humans can. And I will also say for much larger sets of data. So a human might be able to identify a pattern in 100 pieces of data. But when we talk thousands, tens of thousands, millions, humans just wear out. The machine does not wear out. And so that's where AI starts to have its power and bring benefits to human decision-making, choices, understanding, right, is because it can find those patterns in that very large set of data that humans it's just overwhelming. So you may have clients, companies that you're working with who want to use AI, and be helpful to ask them why. So they may find it's helpful to their brand because there's a cool factor. I can tell you that I know of actual startups who claimed they were using AI, who did not have anything that resembles AI at all in their technology set. Okay, they just adopted the words, put them in their documents, and I guess thought no one would ever find out. Unfortunately, people did find out, and so then their credibility was destroyed. So, make sure that when a team wants to say AI or one of these other phrases, that it's really there. There's really some meat on the bones. AI can also improve fundraising, right? It's hot. You want to raise money, you say you've got AI, that's great. But again, you've got to have the real deal. You've got to have the real deal. Now, AI can do a lot of things. This is just a small collection, right? It can improve customer service, improve our understanding of our customers or of market dynamics, improve customer overall corporate performance, right? Give us insights that we didn't have before, and lots of other applications because it's being used in many, many fields. But, and this is the risk part, AI can introduce bias, can help make companies run afoul of regulatory requirements, which in some industries is very important, and can cause chaos. And we're going to talk about how that happens, not intentionally, but how it can happen in AI. So this statistic is, you see this in the news. If you look up Gartner's prediction, this prediction that 85% of AI projects will fail. That's pretty serious. Now remember that Gartner has lots of very large clients. And this is based on their research with their clients and deploying AI, et cetera, et cetera. And what they predicted, specifically, this is actually a quote right from their announcement of this research, that 85% of AI projects will deliver erroneous outcomes due to bias in data, algorithms, or the teams responsible for managing them. That is a really significant issue, right? Even if it were only 50%, it would still be a huge waste of time and resources that are going to projects that don't work. We're going to talk about reasons why, some of the reasons why this is the case. This number doesn't really surprise us, those of us who've been in the industry for a long time. So what I hope by the end of our session today is that you can help your entrepreneurs, your clients, by having an understanding of AI and asking them key questions. So the first thing is that AI is math. It's hard math. It's complex math. It's deep math. It's big math. But it's not magic. It is math. And that's an important thing to understand, right? And I want to share with you here the parts of an AI system. What are the elements of a system? And then I'll show you a picture as well to help visualize it. The first thing is a question that we need to answer or a pattern we need to discover, typically again out of a pile of data. My CTO gave me a hard time about that phrase. What's a pile of data? But it could be any kind of data, a big group of tweets sitting on a hard drive somewhere. That's a pile of data. It could be customer data, historical data, parts data, all kinds of data. So you need a question or a pattern. You need a pile of data. Then you need an algorithm, an AI algorithm. We're going to talk about that, what that is in a minute. And you need carefully curated training data. And when we're done, that phrase will make much more sense to you. And then you need a data store. You're going to gain insights from all this data. You have to put the insights somewhere. So it can be a database, but there's other data stores as well, right? So here's an image of kind of these elements, right? On the left is our training data, carefully tagged, curated. We'll talk about that some more. Then above step number 2 is our algorithm and any pre-processing that we need to do. And what happens is we take our training data, we train our algorithm, we test it, we look at our errors. If it's close, we keep it. If it's not close, we make adjustments and we retrain. Sometimes we start over with a new algorithm, and we'll talk a little bit about that as we go as well. Once, though, we have a system that's been trained and tested on this training data, and we feel is good, then we can take it and apply that to our raw data. You can see different kinds of raw data. And then we've extracted that context and meaning, and we put that in our data store so that we can then use it for whatever insights or decision making that we need it for. All right, so this is kind of the big picture, and we'll talk in some more detail. Now, there's a couple of quotes here that I just wanted to spend a minute on. MIT Technology Review did some research, again, on AI. Two big issues: insufficient quality of data, not quantity, quality was actually number 2, pretty serious. Number 1 was talent, shortage of talent. And there is a significant shortage of talent. And I just wanted to touch on that with you as you are working with clients. AI talent is hard to get right now. And let me share with you why. First of all, our CTO, for example, in Clavix, he started working in AI decades ago. But there were not sufficient resources, computing resources, memory, disk, processing power to really accomplish the vision. But he's one of a small handful of people who've been in this space for such a long time. Most people have been in the industry for 5 to 10 years. In order to be really good at AI, we need to take the very best software people we have, people who are already experienced in big systems and big databases, big data, integrating multiple kinds of technologies. And then we send them back to school, right? We don't just say, well, here, learn this new tool, this new AI thing. We send them to school, and it may be a formal degree. Most likely it's not. There's a lot of great professional resources. But to become a real successful creator of AI systems, you have to understand the math behind the AI, how the systems work, how decisions get made, where you can go wrong. And so again, we take the best software talent we have, we send it back to school, and it starts over at the bottom of the pile in terms of AI talent and works and gains experience from there, right? So that shortage is pretty significant. Pricing is pretty high. And someone who maybe has, 6 weeks of a coding camp or even an undergraduate degree, but, not a lot of experience, probably doesn't have enough experience to really master this right away, maybe in 5 or 10 years, but not necessarily right now. And I'm an entrepreneur, and I love entrepreneurs, right? And one of the characteristics of entrepreneurs is complete confidence in your ability to accomplish your goal, regardless of how hard it is. That's kind of part of what it means to be an entrepreneur, right? To have that faith. But in this case, you might be doing an entrepreneur a favor if you challenge a little bit their view that they're just going to figure it out. There are a lot of great tools out there that there were not 10 years ago. And those tools, a lot of them are open source or corporate tools, but there's still this art and science of configuring properly, of picking the right algorithm. That takes experience. So just a thought for you on that. Now, again, the second quote, you got to have solid, clean data, large volumes, well tagged, well organized in order to be successful with AI. So I do see startups say, oh, well, we've got this great AI system and we're going to train it on our clients' data. Clients are starting to figure out that their data is actually the most important part. So again, challenge those entrepreneurs. Where are you getting the data? And I talked with my chief technology officer about this issue, and he said there are a number of open source and openly available data sets, and a lot of work has gone into them. But he said, in general, they are not sufficient to create a real product. So for what that's worth. And then here, again, a quote from Gartner, from that same report in Gartner: data is the fuel, and organizations need to prepare. So even if you have entrepreneurs you work with who are not yet using AI, if they might, have them start carefully curating that data and keeping it and keeping it clean. So again, a couple example machine learning systems, again, deep learning, which is part of neural networking, polynomial-based machines, SVMs. There will not be a test on the example ML systems, but I just wanted you to know there are many of them. And every one of these is a different mathematical approach, completely different mathematical approach. We won't go into the math, as I said, but they are also suited to different problems. And we're going to talk about that some more. So I'd like to use the Venturewrench library as an example. Why? Because I know it from the inside. And when you look on the outside of an AI system, it's not always obvious what's happening on the AI side, on behind the scenes. But I know this library, so I'm going to use it as an example I think will be helpful. So the library, this is an online interface. It's available for entrepreneurs, and it's a curated library of the highest quality resources in 20 topics, 90 subtopics, designed for to quickly get the most useful resources into the hands of entrepreneurs. We use ML of a variety of flavors of machine learning in order to do this curation. And in particular, we ask 8 questions about one resource. So pretend it's a web page that has some PR tips, for example, or some intellectual property information. And we ask these 8 questions. First and obvious, what's it about? What topic is it? Remembering, of course, that there's over 90 choices to answer that question. The quality rating. And quality is can be very subjective, but we were clear to define that question as actionable and useful. Actionable and useful. And in fact, our system is very good at identifying and separating out resources that are actionable and not so much. So the entrepreneur can get just that really useful information. And then we, time, cost, region, things like that. I want to make a note. Not one of these questions is literally answered in the text or in the content of the resource, right? There's no line 3 to go to have it say, oh, I'm in this topic, okay? These are the perfect questions for an AI system. And that's in fact what we did. We have 8 questions and we have 8 completely independently trained AI systems using all of these different AI algorithms. And why so many? Why not just one? Our team has picked the best algorithm for the question. And when I talked about that art and science of AI, knowing where to start, which algorithm to start with, and if that didn't work, where to go next is part of that art, that judgment that's really required. So we have 8 questions, 8 completely different algorithms in use, and each AI system answers just one question. In order to get the complexity of the answers, we have to have those 8 AI systems, okay? So that gives you a sense of when I say pick the question, this is what I mean. Very focused, very clear. And then when we talk about functional specific or specialized AI, that's what I mean. Each of those AI systems answers one question. Now, let's talk a little bit about bias in artificial intelligence. It is a significant risk, but it may not be the risk that pops to mind when we say the word bias, right? We often think of human bias or discrimination. But bias in AI is not all human, and maybe not mostly human, although there can be some that comes in. Bias in AI comes from other areas, right? And these are really, if you will, technical and implementation failings, right? So we're not assuming here malicious people. We are assuming mistakes. And 4 key sources, right? We ask the wrong question. We ask a question that's too fuzzy or not relevant, right? Or has too many moving parts where the AI system can't get a clear pattern. We pick the wrong algorithm, so we get poor accuracy. Remember what Gartner said? Erroneous outcomes, okay? We use the wrong training data. Maybe it's messy. Maybe we've just given the system the wrong information, or we've poisoned the machine. And I will tell you, the first time my CTO said to me, we can't poison the machine. Our data has to be just perfectly curated. I knew a moment of terror because it really is significant. And I'll show you some examples in a minute. So here's an example. We're going to actually learn to train an AI system to answer one question. The system is going to receive an image, any image, and it's going to ask the question, is this a picture of an elephant? Okay, that's our job today, to create a system that will answer that question, is this a picture of an elephant, right? And here's a very, very handsome elephant. So step 1 is to pick an algorithm, recognizing that we may have to pick an algorithm, try it, not succeed, pick a new one, all right? But step 1 is to pick one of our algorithms that is likely suitable for it. This would be an image recognition problem, right? Because we're looking at images. The second is we're going to train that algorithm, train the AI machine. And you can see here that I have some examples of training data, right? Because we're going to train it to recognize elephants. But if we only gave it one picture of an elephant, the system wouldn't be very good. We have to give it generally at least hundreds of examples, if not thousands of examples, and in some very sophisticated problems, even millions. But hundreds of thousands often, usually is sufficient for straightforward questions. But as you can see here, we've got elephants face on. We've got groups of elephants, elephants on the side, elephants fighting. We even have a red elephant because he's rolled in the dirt. Why so many kinds of elephants? Because just like when we're teaching a toddler, say, to recognize a shoe, right? We're going to give them lots of different examples of shoe. The toddler mind eventually figures out shoe. The AI system eventually figures out elephant. All right, so we basically take our software, we put it in training mode, we feed it all of these training images, these different kinds of elephants, and we say, great, we'll test we have a test process, we test, we look at our error. If it looks good, we move on to our next step. We're then going to feed our system lots of images. In this case, these are all, kind of safari animals, right? And we're going to say, we want you to pick out the elephant, all right? And so we feed our system all these different images. And if we've done our job and we've trained our system properly, then the output will be, this is an elephant. And we will have had a successful system. Now, if we did something wrong, it might give us a picture of a zebra and say, no, this is an elephant. And that's an erroneous outcome, right? That's just not correct. Now, I talked about the risk of poisoning the machine, okay? Oh, and again, so if we don't have accuracy, right, if we have these mistakes, then we have to repeat our process, repick the algorithm, retrain, test, etc. But one risk, this risk I told you about, of poisoning the machine. If, as an example, during our training, when we've said to the machine, every image that you are presented is an elephant, and we slip in this handsome lion, we've poisoned the machine, because the model that the AI system has built will be 99 elephants and 1 lion. And the odds of our erroneous outcome have just gone up. It's pretty significant. So again, the quality of that training data, that it's all elephants, is really important. It's really important. So here's a real world example, and one that's been in the press and that you may be familiar with, but it is one that is very relevant. Using facial recognition to identify or find potential criminal suspects. And this sounds great. Great, let's just use all the camera footage and let's find them and go arrest them. Well, it's not quite that easy. For example, what if the algorithm matches you to someone who is a criminal or potentially a criminal, and they come and arrest you? This actually has happened to perfectly innocent people going about their day, because a facial recognition system erroneously said, well, that criminal conducting that crime on that video is this citizen over here. And that's pretty problematic for a free society. So, we're the government, we're here to help. But in fact, the National Institute of Standards and Technology, part of Department of Commerce, is adding a ton of value on a regular basis. They study facial recognition algorithms. And the latest study, just about 2 years ago, looked at 189 algorithms from 99 vendors. So they're taking the algorithm, and these are submitted voluntarily by the vendor, and those vendors can be universities, they can be companies, they can be from anywhere in the world, all comers, and it's all free. It's all free to any one of those entities. They can submit, obviously many of them are submitting 2 or more. NIST trains and evaluates those algorithms based on their data set, okay? So, and it's a clean and controlled data set. And in particular, in this last study, they were looking at the effects of race, age, sex, and face on face recognition software. All right, so this diversity question, how good are they? And here was their summary. Different algorithms perform differently. All right, good to know, but not as good. Facial recognition systems consistently are less effective for women. That's roughly half the population, right? False positives, false matches, meaning the systems don't really have a good handle on women's faces, okay? But an even larger effect is the lack of effectiveness for people of color. False positive rates can vary by 10 to 100 times for people of color. That is very serious when there are so many people we call people of color, but there's so much diversity, when we have such serious error rates, it's very significant. And then also the systems are less effective for the very old and the very young. You can ask yourself, who's left? It's a pretty small group of people that the systems can work accurately on, okay? And I will note, by the way, that systems from different countries did better or worse depending on their population, because of course it comes down to training data. What training data were you able to use, okay? So real world impact, of course, who cares? Well, there are commercial systems that have been offered, some of them are being pulled off the market, who've been offered that are dramatically less effective, right? And there is a system who will remain nameless, who has collected a database of 3 billion images. Unfortunately, those images are stolen. Now, what do I mean by that? Those images are scraped off of social media sites. So if you posted a picture of your kid's birthday party and tagged all the kids and the parents who were at that party, that data has likely been stolen and included in a facial recognition database. Now, it's also been stolen because technically the social media sites own that data, and they've not given permission for this application. You didn't give permission for your data, and the social media site didn't give permission. And yet this same company goes to police agencies and sometimes individual police officers and says, hey, use our system for free for 30 days. See who you can find, right? Well, that's a problem. And we're going to talk a little bit about regulation coming. Regulation is coming to prevent this kind of issue, all right? And again, there have been real people who have been arrested based on false matches from facial recognition software. So, for example, some cities and states are banning or limiting the use of facial recognition software. They may be requiring a warrant, or they may be requiring human oversight instead of just saying, sure, yeah, it's right, sure, we'll just trust that. Now, I want to talk to you about another challenge that we call brittleness. AI is brittle, and brittle in this case is really the opposite of resilient. And this is the elephant in the room experiment, and literally is an elephant in the room. All right, so this is Quantum Magazine published this study, and on the left-hand side, and it's a little bit of a complex picture, so forgive us, but on the left-hand side is an image, and this is an object recognition application, and the job was to take this image and to identify, and really quite accurately, all of these different items in the room. All right, and then the researchers added an elephant, and if you follow the little orange arrow, it's pointing to the picture of an elephant on his side, and he's basically just hovering in the air over the head of our gamer. I love how the researchers used game night as their topic. But this elephant was just plunked in the room. And you can imagine that perhaps the system that's being trained to recognize objects in a room might not recognize an elephant too accurately, and that will be correct. It did not recognize the elephant very well. But at the same time, the system's ability to continue to recognize items that it had previously successfully recognized went down on many of the items. Either it missed them altogether, just didn't find them, or it misidentified them. Okay, and this is a problem because we've taken a system that was working very well, and just by modifying the image it's looking at with something extraneous, the elephant in the room, we've diminished its overall capability. Now, a real world example of this is the stop sign problem. So self-driving cars and driver assist cars were trained to recognize stop signs. That's actually a really crucial element of safe driving, right? To recognize and stop at stop signs. What happened very quickly, though, was that it became clear that you could sabotage the stop sign recognition by simple things: changing the paint color on a stop sign, slapping a bumper sticker across the stop sign, changing the word in the stop sign, so that the training had been so narrow that it was very brittle. And the slightest thing could actually cause real world catastrophes. Just throwing a bumper sticker on every stop sign defeats all the self-driving cars, right? That's very serious. So these are problems that are being worked on in AI. They're areas of research. This is actually called adversarial AI, where we practice what happens when we break the system, and then how do we make it more resilient, so that when we're looking at real world examples and real world applications that we rely on, they'll be more resilient. So here's just a little thought experiment. A mortgage company is in a town or a region where pretty much the north side of the town has been where all the development was. The south side was just a big farm. There were no mortgages because there were no houses. The family just owned the farm and farmed away. And then the south side, the family sells the farm and development begins, right? And at the same time, this mortgage company decides we want to use AI to help us underwrite mortgages, right? Seems like a great application. Let's comb through the patterns of our successful mortgage applicants and create an AI system that will help us. Now, here's the challenge. If you, the AI team, just take all the data that you have ever had and feed it to that AI system without carefully thinking it through, you likely will train a system that looks at north side addresses and says, that's a good risk, and looks at south side addresses and says, we have no successful mortgage applicants from the south side, so the south side of town must not be a good mortgage risk, even though what it really means is we don't have any data, right? So thinking about how do you carefully select the data to train your system for those relevant elements. Now, I talked about how bias in AI is not necessarily human, but this is a case, literally the mortgage case, is a case where historically we may have actual human bias embedded in the data. That's why we have regulations against bias in mortgages, right? And if we use data that encapsulated human bias, we have just now embedded that historical bias into our latest and greatest system, which is obviously very significant and of great concern to people who are thoughtful about AI. So regulations are coming, but as always, regulation is behind tech, right? Technology develops faster, humans create faster than regulations can keep up. But they are coming. They're coming internationally, they're coming nationally, they're coming at the state level. And they're in fact coming more at the state level right now, and some municipal level, but mostly state level. And national, I think, is going to come next. So and in fact, we have a page on our blog, venturewrench.com/SBDC. And on that page, I'll have links to a blog post that I wrote that actually discusses this issue, the proper use of AI and the regulatory concerns at some depth. And that link will be there for you so that you can read more about it and you can share that with your entrepreneurs who are considering AI. And I literally had a press inquiry come across my desk that said, how are you scraping data for your AI system? Right? This was a journalist who just assumed that was appropriate. Not so. And soon, really not so. So best practices from the beginning is the best way to go. So I encourage you, when you think about AI, both in terms of your clients and your professional work and your coaching and in your personal life, be accountable. Demand accountability from companies that you do and organizations that you do business with and from your governments, and help your clients use these technologies wisely so that AI can be of benefit to them, to their businesses, to their clients and customers and partners, and to society as a whole.